okay? And the reason I'm not picking on Jerry and Michelle here, I appreciate that they jumped in this. They just taught an awesome lesson yesterday, so I know they're going to have time to think about this more, and I'm going to ask them to get up around 2. But equations, okay? This is a place where engineers have a lot of problems, is when you give kids equations, you've got to make these concrete. Remember when we did pressure equals force over area, and I jumped in there too? Okay. Because you have got to reduce the amount of variables that you give kids at a given time, all right? If you want to teach, for example, let's go with whatever one of these we think kids would know better, okay? We're going to assign something a value. 6th graders, when we turn these into fractions, did they get pressure force over area? Yes, but they got it as a fraction, right? As numbers, okay? So let's say, and I'm just going to, let's say, okay, so in this example you were saying the mass is, these have the same volume with a different mass, right? That's what you're trying to show, okay? So they have a different, so let's just make it an actual fraction for kids, okay? So instead of making it like hypothetical, you're going to try to make it concrete and let's visualize something. So if they have the same volume, let's give a number that's, and I know that I want, okay, I'm going to make that number 10, okay, because I want it to be not an improper fraction, okay? So I'm going to say the volume of these is both 10, right? Does it matter what I give to this value? And I can even ask the students this. No, because they're the same size, right? So I'm just giving it a value that I know is the same. So let's say it's both 10. Now here I have a mass. How much stuff is in here? How much? 2, okay? And here I have a mass of what? 4, okay? So now what I'm going to ask students is, and this is a little tricky because I might have to simplify it. This would have been easier if I put 5 or 7, right? Because then I wouldn't have to simplify it. So let's just say I put 5. Okay, now I've got to ask students in my 6th grade class, which of these fractions is the larger fraction? Okay, and students will have to think about it for a second, but they'll be like, okay, which one's the larger fraction? 4/5, okay? They want to have the same number on the bottom, whichever number up here is going to be the larger fraction, right? If this is a piece of pie, I got 2 pieces out of 5, or I have 4 pieces out of 5. So this is the larger fraction. So this one has the greater, so this is a greater density. Okay? This is a lesser density. Alright, do you kind of see where I'm going with that?